We are welcome to the last episode on time value for money, and here we are looking at the third application, which is the investment appraisal. When we talk about the investment appraisal, mostly we are looking at the investments we make in projects. You might have one or more projects to deal in, and you want to know the best option, the best project to take given the time value of the project, and that is why it is an application of time value for money. The techniques we go through, we don't just look at the project and say, hey, this is suitable to do. But then the techniques to evaluate it, that is why it's investment appraisal. In this course, we are not going to take all the techniques. We'll have just the first three, but for this presentation, I'm going to take the last one because Excel has an inbuilt function for it. Okay, that's the net present value. We want to accumulate and see the present value for all the accumulations over the period of the project. I wish I'll be able to explain the first two before I take the last one. So let's take the regular payment. Regular payment do not give you any amount. It rather gives you the rate at which you would cover your investment. Okay, and the discounted rate it's just a cover for the regular payment. Here it takes into consideration the discounted cash flows. Okay, unlike here there's no time value of money. In addition, we just check the time to recover the investment, so it gives you like a number of periods. It will give you, okay, you will take 5 periods to recover your investment. You're going to take 2 years to recover your investment. That's what the regular payment do. But discounted is an upgrade of the regular, where now the discount comes in, the rate comes into play. But more interesting, we want to look at the net present value, which takes into consideration all the cash flows respected to the discounted rate, and that is why we want to look at it. So I have a table here for you. It says, does payback takes time value for money? No. Discounted and NPV, yes. What are the decisions? If your payback is less than the target, you are good to go. If your NPV is greater than 0, it means if it's positive, you are going to choose the project. Okay, and so let's take an example here. It says the local government is looking at having a rural water project to improve the clean drinking water of the community, and it says it has an initial project value of 50,000. That's the investment to make, and then it's expected that at each year they will have a profit or inflow of 12,000 each year for 6 years. The project is going to span for 6 years, and then the discount rate on this investment is 8% per year. It says you want to evaluate the project. Should the project be executed or not? And so before we take the solutions, okay, let's see what we have here. If I'm going to use a payback period, which I didn't go through how to compute it, it says you will need approximately 5 years to recover your investment. Probably there's not enough information for you. But if I use a PMV, it says that I'm going to retain a profit of 5,466 Ghana cedis if I should go ahead with a project. Okay, and that is what we have to do. So decision, because it's more than the target was 6 years. Since it's less than the target, we are good to go. It means we will reap in 4 years' time instead of spanning for the entire 6 years. Discounted rate says you are going to reap harvest in 5 years, which is still within our time frame. And then NPV also says I'm greater than 0. It means I'll give you profits at the end of the day. So accept this project. Okay. I get that was a very quick one explaining, but let's take the Excel sheet for NPV. Okay, so that's what we do. Before we solve the main question in the slide, I want to take you through some example here. So it says that a project requires an initial investment of 22,225,000. Because it's an investment, it's a cash out, so it's negative number here. And then it is expected to generate 95,000 in year 1, so year 1 95,000, in year 2 is 80,000, year 3 is 60,000, and year 4 55,000. It says compute the net present value if the return is 12% here. So how do we do that? So we don't want to use a formula given here. You see the net value here. If you want to go by the formula, you can quickly do that, but interestingly, Excel has an inbuilt function for this NPV, which takes into account the returns, the rate, and then the initial investment. So let's see how that is done. So you just type equal to NPV. So it says it's giving you the net present value of your investment based on series of periodic payments and a discount rate. So equal to the rate, we pick this rate, and then the values. We are going to start from year 1 because year 0 is when the investment was made, and we already have our value. I want to take from year 1 to year 4, and then that is not all. We must subtract the initial investment, but because it's already in a negative form, when it's positive, and then that number by the formula. And so that is what we have. It says that at the end of the 4 years, you are still going to have a positive cash flow of 1,257 cedis. So since this is greater than 0, we accept to get the project done. Okay, now let's go to the formula one more time. Look at it. It says minus the initial investment. So that's why I already had negative there, and so I'm going to take plus. And this part is from time 1, from T1 to Tn. Okay, so we are starting from year 1 to the last bit. So that is it, as simple as that. Let's take in the case where you have more than one project. Okay, it says the cash flows of 2 projects are given below from time 0 to time 5. Project 1 cash flows are this. So there's the investment, initial investment of 10,000 for each of them, and then there are various cash flows as the year goes by with the rate of, I think it's 5% instead of 50. Yeah. Okay, so it says which of these projects should we take and why. You want to calculate the net present value for each of them. So the rate of 5, and then we start from 1 to 5. Okay, and we come out of the, oh no, let me take it again, 1 to 5. And then that's not all. You have to subtract or add the first term, which is the negative 1,000, to see the actual net present value. So that is 245, and this is equal to, I want to pick this first one, okay, plus NPV into bracket the rate, comma, all the other values here. Okay, so look at the difference in the values. Since they are all greater than 0, this is greater than 0, this is also greater than 0, so we must accept the project. Okay, but then we want to give some extra condition. Accept, yeah. If they are mutually exclusive, let me start with the independent. If they are independent means that the project has no influence over each other. Okay, project A has nothing got to do with project B. And so if they're independent, you are good to choose any of them that is greater than 0. I think I have it in my slide, so let me show you what I'm trying to talk about. Oh, okay, I thought I had it in there, but that's fine. If they're independent, that is what it means. You can choose any of them and then you are good to go. So either project A or project B is good to be accepted. But if they are mutually exclusive means that when you have to choose one and neglect the other automatically. So if you choose A, you're going to neglect B. If you choose B, I'm going to neglect A. That's a choice to make. In here, we check the one with the highest NPV. Okay, so if you check these two guys here, it means that we have to accept project B, but that has a higher returns at the end of the day. It has 336 and project A has 254. So if it's mutually exclusive, we have to go in for project B. If it's independent, we are good to choose between any of them since they are all positive. And that is how the NPV is done. So yeah, I have it here. Now let's go back to let's take another example here. Assuming I have 3 projects and then the initial cost here, their annual cash flow for 6 years with this discount. Assuming I've calculated the NPVs, okay, and then I have these values up at 10. That is the assumption. I have these values at 10. It says that which of the projects would you go for if they are independent, and which of them would you go for if they are mutually exclusive? So if they're independent, as far as they are all greater than 0, I can accept project A, project B, or project C because they are all greater than 0. It says choose any of them. But if they are mutually exclusive, I'll have to go with the one with the highest NPV, and among these projects is project A. I would have to go for project A as the choice. So that is how the net present value is calculated. So I think we can now go ahead and take our main example. It says initially it was negative, it was this cost negative 5,000, and then it was 12,000 for each year throughout for 6 years. So I'm going to copy this guy and paste here, paste it here. It means we have the same cash flow at the end of each year for 6 years, with a rate of the rate given us, did I have a rate 8%? Okay, so let me color this part and let's calculate the NPV for this project. So this equal to NPV. I always want to start with the first number so I don't forget, plus NPV of everything here. Let's see. No. NPV takes a rate, so it is already there. So the rate here, and then all the other cash flows. So it says this is what you're going to have. I think there's something wrong here because it is even more than, okay, so that's a 5,000 here. That is correct. So it is still greater than 0, and so we can accept it. The initial investment was 50,000, but at the end of 6 years we still have some revenue coming in at 5,000, so we can accept the project. And so this is how simple net present of value is being calculated. You don't forget, always have your initials at negative and then add them. You can pause this video and go over the examples one more time. Thank you very much.